we're being asked to write a function for this graph. It's kind of important to remember parent functions when we do these. I have 1, 2, 3 bumps, so this looks a lot like an x to the 4th equation. However many bumps it has, usually it has one more than that as the highest power. So 3 bumps means one more than that, 4 as the highest power, x to the 4th. But we'll go ahead and just build it and see how it develops. A good thing to note is that when it crosses at an x-intercept, usually we just have one of those factors. When it bounces like this, it usually doubles up, or it's like a squared set of that factor. So I'll go ahead and set up the general form, and then I'll deal with that 1200 that plays a part in this. So the general form for this function, f of x, is going to be, so whatever this intercept is, it's the opposite of that number is what goes inside that binomial. So the opposite of -6 is +6. And then what did I say about the bounce? It's squared. It's kind of doubled on itself because it bounces. And then the same thing for this one. What would I write for a bounce at 5? It'd be x minus 5. And since it bounces, it's that squared idea. And it should make sense. This is the x, this is the y-axis. So that's at 0 on the y-axis. So at 5, it has to 0 out for the output. At 5 minus 5 is 0, and it zeroes out as an output. Same thing for -6. It touches at -6. That would be a 0 for the y. -6 into here, it zeroes out and everything turns to 0. So far this looks good. Now we need to make sure that it crosses at 1200 on the y-axis. So it has that output of 1200 for y. The trick is we add an extra variable here, a, and we'll make it so where it has to force it to have that output of 1200. Remember, this is 1200 on the y-axis. So that's like an output of 1200. And we have to put it right there so it doesn't affect where these land. Because if you're adding or subtracting something, then if you plug 0 in here, it doesn't zero it out because you're adding or subtracting something else. So we're kind of stuck with it as a multiplier. So I'm going to go ahead and rewrite it. We have to have the output of 1200. So f of x turns into 1200. We have an output of 1200. This is that new variable that we're solving for as a multiplier. And then everything else stays the same. Okay. Now we say, okay, well, what's kind of the easiest number we can plug in for x to kind of deal with this? So the easiest number to plug in for x almost always is going to be like a 0 that zeroes things out or makes things simpler. So in this case, if I plug in 0, that's just going to make it a little bit simpler so I can solve for a. So let's go ahead and let x equals 0. That's going to go in there, and then that's going to go in there for 0. So this now becomes 1200 equals a times, that's 6 now, that's all that's left, that's why I use 0. And then that's a -5. Is that zeroed out? Okay. Then we'll go ahead and simplify a little bit more. We got 1200 equals a, 6 squared is 36 times, and -5 times -5 is +25. And let's go ahead and see what 36 times 25 is. 36 times 25, I think it's 900. It is 900. So it's 1200 on the left equals a times 900. That 900 can go in front or the back. It doesn't really matter here. I'm solving for a. So I divide by 900 to get a by itself. And now I'll go ahead and do the work right here. I got a equals, all the zeros kind of go away, so I'd have like 12 over 9. That's how I kind of think about it. I make it a little bit smaller right away. And then both of these are divisible by 3. So 3 goes into 12 4 times, 3 goes into 9 3 times. So A is 4/3. Nice. Now I got my A. I'll go ahead and plug everything into this function right here. Remember, this is what it was like just to have those as intercepts or bounces, and then we need that A in front. So the f of x, I'll give myself some more room, I'll put it down. So my f of x turns into, the A was 4/3, and then I just repeat my binomials, x plus 6, quantity squared, and x minus 5, quantity squared. And there we are. Okay. Next one says, draw a function from the sign chart. Draw a function from the sign chart. Well, this isn't too bad. It's just telling us where our outputs are positive, negative, and positive. Where the output, where the y is positive. So it's basically above the x-axis right here, below the x-axis, above the x-axis, where the y's are positive. It also, that means where these dots are, where it touches the x-axis or crosses. If we have a sign change, that means it's crossing the x-axis. If we don't have a sign change, that means it bounces on the x-axis. All right, so let's go ahead and draw our x-intercepts first. That's how I would do it. This is the x-axis, this is the y-axis, negative x, negative y. So this kind of really helps having those x's, negatives, y's, negatives, and positives, because it really links together with our sign chart. Remember, these are the outputs or the y's. Okay, so I got negative 4 on the x-axis, I got 1 on the x-axis, and I got 4 on the x-axis. We can put dots there because our graph has to touch at those points. Then we said, okay, that's a bounce right there. It stays positive. So this is from the positive side. Positive side comes over and it bounces. Okay, and then it's going to cross right there. It goes from positive to negative. So that's to cross at the 1. And it doesn't really matter what kind of behavior it has in between these. We just want to make sure it stays in that positive side or negative side, depending. And then it crosses again, it goes from negative to positive. It crosses again at 4 and then keeps going in those directions. Everything kind of looks good on that side. I wonder, what kind of parent function would this be? I got 1 bump, 2 bumps, 3 bumps. Oh, that looks like a 4th degree. All right. And that kind of completes that for what we want. This one says, draw a sign chart from the function. Okay, so let's go ahead and I'll get started with my sign chart. First thing I want to take care of, it's already in factored form. Oh, that saves us a lot of work. That helps us, what are the x-intercepts? So I'd like to go in order on these. So let's see. I'll take care of the most negative one. So the x-intercepts, x-intercepts. The x-intercepts right here, that's a negative 1. That's a positive 2. It's basically the opposite of whatever that is. The math behind it would be x plus 1 equals 0. That would zero it out. So if I subtracted 1 from both sides, that's where the negative 1 comes from. It's basically the easy trick is it's the opposite of that number. Whenever there's nothing in front of it, I always take the time, if there's something in front of it, then go ahead and solve that part for 0 so you're absolutely sure. And if you're still a little bit questioning, plug it back in just to make sure. So I'm not sure if 2's the answer for this as a root. If I plugged it back in, 2 minus 2 makes 0. That confirms it. So the other x-intercepts, what's this one? Negative 5. And what's this one? Negative 3. Be careful, don't forget about that square right there. That means there's a bounce. And then, like I said, I want to order them as I put it down. That makes my life a little bit easier. So going from left to right, this is negative, this is positive. From left to right, -5 is the first one I see. Then -3. Then -1. And there, I like having 0. Just be careful that you don't touch 0. I just like having that as a placeholder. And then we have 2. 1, 2. So I'll put the ones that are answers, and then I like having my 0 as a placeholder. That just gives me kind of a sense of my origin and where I'm kind of coming from. And let's go ahead and fill out the sign chart. Now the trick here is, if there's nothing negative in front of here, then all of these, as they go to infinity, as it goes to infinity, it's going to keep growing, growing, growing. If there's a negative in front here, then that means it's going to shoot down into negative infinity. So the key is, as x goes on forever, that's going that way, this keeps growing, growing, growing. So what that means is we always start off with these as a going to infinity. And when I say going to infinity, I'm talking about y. Y goes to positive infinity on these, as long as that's not negative. If that's negative, it throws the whole thing down and flips it going down. Okay? So since this is positive in front here, and we can't factor anything out to kind of switch it around, we are going to positive infinity. All right. So I like putting dots at everything I'm focused on. Don't put it at 0. That was just my origin. So I know it touches all of those. And then we have to connect it with sort of the dynamics of what happens here with bounces or crosses. Remember, a square here bounces. Without a square, it crosses. So here we go. We'll go ahead and 2. 2 doesn't have a square, so it crosses. So I'll go ahead and go down there. Then -1. -1 is this one. It doesn't have the square, so it crosses. -3. -3 does have the square. This is the bounce. So be careful. We bounce on that one. Don't cross it. And then lastly, -5. The only way I can go to -5 if I come back down and keep going that direction. That's the only way it can kind of happen. All right. And that's how you kind of build this. You have to start on this side when you're kind of building it, because of that in behavior pretty much defines everything else that kind of goes on with the rest of the function.